Today's lesson is about using models or representations to show fraction problems that are multiplying problems or dividing problems. So by the end of the lesson, you're going to be able to draw a representation of a math problem, and you're going to be able to interpret representations to figure out what math problem it means. Let's get started. Here's your first example. So this problem shows not only the representation in the grid, but also the math problem that you would solve if you were just doing traditional math. So here the problem is 2/3 times 5/7 equals 10/21. You'll notice 7 columns and 3 rows in this picture. There are 10 green blocks. There are a couple different colors. We're going to figure out what all that means as we go through the lesson. So how do we draw this? What we do first is start out with a blank rectangle or an empty rectangle. And we're going to draw rows and columns in this rectangle. The first fraction is going to tell us how many rows to draw. So here, if the denominator is 3, I'm going to draw 3 rows. Since the numerator is 2, I'm going to color in 2 of those rows. So what that does is it shows the first fraction in the problem, 2/3. The second fraction, 5/7, I'm going to do the exact same thing, except I'm going to go up and down or vertically instead. So if the denominator is 7, I'm going to draw 7 columns. 1, 2, 3, 4, 5, 6, 7. And I'm going to color in what the numerator tells me to, 5 of those columns. So the numerator of 5 means the color 5 in. 1, 2. And what you'll notice is some of the blocks are different colors. I'm trying to color all of them yellow, but what you probably learned in art class is that yellow plus blue makes green. So as I draw these yellow columns, these blocks where the blues overlap with the yellow are going to make green instead of yellow. So I'm going to color in the 5 columns. There's 3, there's 4, there's 5. And where the blue and yellow overlap, we have green boxes. So now we have our picture. Let's interpret what this means. The green, where they overlap, is going to tell us the numerator in the answer. So there's 10 overlapping blocks, which means there's blue and yellow in them. The denominator comes from how many blocks are in the entire picture. We created a picture with 21 blocks, so that means that 21 is the denominator. And 10 of those 21 overlap. So that's how you interpret this representation. You first look at how many columns and rows there are. Those are your denominators. You look at how many of the rows are colored in. 2 out of the 3. How many columns out of 7 are colored in? 5 out of 7. And then the overlap is the numerator, the total boxes is the denominator. So another way to see it, I'm going to separate them so you can see it better. Here's what 2/3 looks like. Here's what 5/7 looks like. One is going sideways, one is going up and down. When I overlay one on top of the other, the yellow and the blue make green, and then there's those little spots of yellow and blue that aren't overlapping. You'll also notice that the up and down, the vertical lines and the horizontal lines make boxes. Those boxes are what you count to get your answer. So let's do some practice. Draw a model for each problem. When you finish, you can hit play, and we'll see how you did. So start with a blank rectangle, do your rows and columns, and see if you can do your shading correctly. Okay, here are the answers to the problems. So what you'll notice in problem 1 is that there are 4 rows because 4 is the first denominator. And I colored in one of those rows in blue because 1 is the numerator. For the second fraction, I did 5 columns because that's the denominator. And I colored in 3 of those columns because that's the numerator. So count the number of blocks that overlap. 3 blocks overlap, yellow and blue make green. And when you count the rows and columns, there are 4 rows and 5 columns, so you could multiply, or you can count every box if you want to. There's 20 boxes. So 3/20 is the correct answer. This one here, since 8 is a larger denominator, I decided to make columns first this time. It doesn't really matter if you make rows first or columns first, as long as you count them correctly. So here I did 8 as the denominator, so I did 8 columns, and I colored in the first 5 in yellow. Going sideways, the rows, I did 3 rows, and the numerator tells me to color in 2 of those rows. So the 2 rows are colored in blue, where the blue and yellow overlap, they make green. And 10 out of 24 is the final fraction, because 10 green ones out of 24 total. So that looks a little bit different than our answer, but don't forget you can always simplify before you get a final answer. If you take 10 24ths and you simplify it by dividing by 2, you get 5 12ths. So now let's model division problems. I'm going to show you two ways to model. The first one is by making groups. So here we have a problem, 3/4 divided by 3/10. 3/4 divided by 3/10. And we know that equals 2.5 because if we do our keep, change, reciprocate, and solve, that's what we get. So here's the questions really asking. Division problems are usually asking, what is the number of 3/10 groups that I can fit into 3/4? How many 3/10 will fit into 3/4? So I'm going to show this visually. This is what 3/4 looks like, and this is what 3/10 looks like. So I'm going to try to fit groups of orange into the yellow. And I want to know how many orange groups fit into this yellow space. So what I'm going to do is kind of overlay them again like I did the multiplying and then count how many groups I can make. So the first thing I'm going to do is start out with my 3/4. So if you notice there's a dashed red line here, that's going to show the fourths when I overlay the tenths on top, just so we can keep track of what's going on. Okay? So this is 3/4. If I take my tenths and lay them on top, now you can still see the 3/4 on the bottom, but I have my tenths here, and what I'm going to do is make groups of 3/10. How many groups can I make? There's one group of 3/10. There's two groups of 3/10. And then this last part, it has 1.5 blocks. 1.5 is half of 3. So if I take this space right here, that's a half of a group. It's not a full group. So I was able to make 2.5 groups out of that yellow space when I break it into 3/10. So I made 2.5 groups, so that's the quotient. Okay, a second way to show this is with number lines. So what I'm going to do is I'm going to make two number lines. One of the number lines is going to show the tenths. The other number line is going to show the fourths. Okay? So you can see here that some of the, this fraction here is simplified. So that would be 2/4 obviously. None of the tenths are simplified. That's going to be helpful. So here's what I want to do. I want to see how many groups of 3/10 again does it take to get up to where the 3/4 line is. So the 3/4 line is right here. And I'm going to start just drawing arrows from 0 out 3/10 each time. And I'm going to see how many arrows I can draw. Okay? That's one 3/10 jump. That's two 3/10 jumps. And then I have this space here where I can jump not 3/10 but 1/10 and then a half of a tenth. Again, that's a half of one of these red lines. That's a half of a jump. So that's a half of a 3/10 jump. So this visual is also showing you 2.5 jumps, which means that 3/4, where this red line ends at, or the dashed line ends at, if you break it up into jumps of 3/10, you can do 2.5 jumps to get there. And that's another visual way to show what 3/4 divided by 3/10 is. So again, if you wanted to double check, you could do keep, change, reciprocate, but that would be your final answer. Okay? Just so you're aware, when you have to do homework and quizzes, you may be asked to see one of these and then determine what math problem is being shown, but you will not have to construct one of these from scratch. Just like the other problem with the groupings. You're not going to have to make division problems from scratch, but if I show you a picture of one, you're going to need to know what it means and what math problem it's showing. Okay? That's different than the multiplying. We're expecting you to be able to draw multiplying problems because they're a little less complicated, and it seems like that in general, 6th grade math students can usually do that successfully. Okay? So here was today's lesson. You're going to get some practice to do in class. So use the video as always. If you need help learning how to draw the multiplying ones again, replay the video. If you need help using this model here that you can see as an example for when you're trying to decide what division problem is being shown in a picture, you can bring this back up and then use this to help you ready for your quiz. Okay, I'll see you next time.